In today's movie, I'm going to complete the second part of the document object-oriented programming. So let's go to my home page and go to the schedule. Currently in the fall 2017 semester, click on any of these links to go to the schedule for this course. This is CSCI 120 and the current semester is fall 2017. The topics will be similar for all semesters. Now if you scroll down to the current week, which is week 12, we're now programming with classes. The document that I'm going to use is this one. This is a PDF document. In the previous movie we covered the first 21 pages of this document. So in today's movie I'll do part 2, which is the remaining pages of this document. Now this document is a PDF document at this address, and we're also going to be referring to programs, example programs. I'll show you where they are. So if you go to my home page here and click on Python, you will get the link to the example Python 3 programs. And the programs we're going to use, in the last movie we used program 1301.py, which was this one. Excuse me. And we created 2 person objects, and this is the definition of the person class. And in here we've got 2 special methods. One is called init, which will initialize an object of the person class with their first name and last name. The strip method will return the state of the person object. Essentially what that means is it will return the value of the instance variables first name and last name. So today's movie, I'm going to look at the remaining example programs, starting with 1302. Now let's scroll down to the screen, or the page 21, and this is where we left the last movie. So in the last movie we ended on program 13-01.py, and this is the program that I'm referring to there. In this movie we're going to look at the remaining programs, 1302, etc. Now before we do this, I want to explain the 4 fundamental object-oriented programming concepts, and these are 4 very important features of OOP, and all programmers must master these concepts. Encapsulation, abstraction, inheritance, and polymorphism. Now I'm going to explain as well as I can in this movie each of these 4 topics. Obviously I won't be able to go into much detail in this movie, but in next movies, in future movies I should say, I will be going into more detail in more advanced programming concepts. Okay, encapsulation. Now we've come across this before. What does it mean? It means putting data into capsules. And let's see. Encapsulation is a mechanism of wrapping the data, the instance variables, and the code acting on that data, these are the methods, wrapping them together into a single unit, a capsule. So encapsulation provides data hiding from outside of the class, and it hides the details of how the data are stored and how the data are manipulated. So this information is hidden. So Encapsulation involves hiding your instance variables. Now this means making them private. Now in other languages it is possible to actually make the data private, but Python doesn't actually provide the ability to make instance variables totally private. But by giving instance variables a name which starts with the underscore, this is a signal to the programmer that this variable should only be accessed by a method that belongs to the same class. So let's move on to see how that works. So methods of a class, these have public access, so that code from outside of the class can invoke or call the method to view or change the value of an instance variable. Now hopefully when we look at some of the programs this will become clear. So you may need to go back and review the material that we're covering today in order for it to make sense. Now there is a special method called an accessor method which allows you to view the value of an instance variable but not change it. So if you just want to have a look at the value of a variable in an object, then we'd use an accessor method. Now if we have an instance variable called first name and an instance variable called last name in our object, then in order for us to be able to inspect the value of those variables, then we can use an accessor method. Now as a programmer you have to define your own accessor methods. And here I've got an accessor method called getFirstName, and in the parentheses we have the word self, which is a placeholder for the object itself. So when we call the getFirstName method, we would call it using the name of an object, a dot, and then the getFirstName method name. Now all methods of course have got the parentheses. Now the getFirstName method, the purpose of this method you can see in the docstring. The docstring here says returns the instance variable underscore firstname, and that's exactly what it does. This method returns instance variable underscore firstname. Now the word self is referring to the object which is calling this method. So if we have an object called person1, then self is person1. If our object is person2, then self would be person2. So self just stands for the object itself. Now accessor methods are read-only. They can only inspect the value of an instance variable. They're not intended to change the value. Let's look at program 1302. Okay, there's 13.1, this is 13.2. Now this is the same as program 1301, no change there, but here we've got the two accessor methods. Now accessor methods, the purpose of an accessor method is to get the value of the instance variable. So get first name will get the first name, get last name will get the last name, and so accessor methods, generally we start the name of an accessor method with the word get. This is a signal to the programmer that this is an accessor method. Its purpose is to just inspect the value of an instance variable. So because we have two instance variables, here I've got two accessor methods, and here is the docstring. Now remember, there is a docstring for every method in a class, including the special init and str methods. And the docstrings, note, are indented to the same level. So here if we have this init method, the docstrings are indented to the same level as the statements within that method, and that's important. And you can see it's the same for all of the methods here. So in the previous code we saw how the doc method will print the docstring for a class. So we give the class name a dot and then the underscore underscore doc underscore underscore. This will then return the doc string for the class, in which case this is the doc string for the class. Now here I'm creating two objects. The first object is called person1, belongs to the person class, and to the init method we're sending the string Anne and the string Dawson. Now Anne will be passed into the first name parameter of the init method. Dawson will be passed into the last name parameter of the init method. Now remember, the init method, the purpose of the init method is to initialize the object. So we're generating the object using the init method. We can call this the constructor method. It constructs the object. Now notice we don't actually call the init method here. It's called automatically by generating the object in this way. So to create an object, you give the class name and then any arguments you want to pass to the init method to set up the initial values of the private instance variables. So if we print and give the name of an object, this will then implicitly call the str method. The str method, the purpose of the str method is to return the state of the person object. And the state of an object is essentially the value of its private instance variables. Now, here I'm calling the doc string of the getFirstName method of the person class. Now, if you call the doc string of the getFirstName method, what will be printed is this doc string. You could also call the doc string of the, or you could call the doc method of the getLastName method, and it would return the doc string of this method. And you can try that yourself. Now here I'm using the getFirstName method on the person1 object, and this will get the first name of the person1 object, and that will return the name Anne. And here we have the getLastName method called on the person1 object. This will return the name Dawson. And similarly, we could get the first name and last name of the person2 object, who has a first name Tom, last name Lee. So let's try running this code then. I'm now going to, I won't bother with the comments at the top. I'm just going to copy this. And so I've already previously opened my Python environment, so I'm going to create a new file and paste in the code. And now, since this one is called 13, this is program 13-02.py, so I'll save it as. I'm going to save to my desktop, and I'm going to call this code 13-02.py. Okay, so now let's see what's going to happen. So here we've got the definition of the class. Now all classes should have an init method that initializes the private instance variables of the class, should have a str method which returns the state of an object. That's basically the values of the instance variables. And a class should always have accessor methods which give you access to view the content of the private instance variables. So you would have an accessor method for each of the private instance variables within a class. So in this case we've got two private instance variables, so we have two accessor methods. And there it is. So the comments here explain what's going on in the code. This is pretty much self-explanatory. We're getting the first name of person1, get the last name of person1, and so on. So let's see what happens when this runs, and there it is. So the first output is the docstring for the class, and you can see the docstring for the class is here, and that's what's printed here. And then we create two person objects, and this output results from these two print statements. So here we have it calls the str method, and that's going to return the first name followed by a space and the last name of that person. Person 1 is Ann Dawson, person 2 is Tom Lee. Now this line will call the docstring for the get first name method, and the docstring for the get first name method is this. So our output is returns the instance variable first name, returns the instance variable underscore first name. Now the last four lines call the accessor methods get first name and get last name on the two different objects. So person 1 is Ann Dawson, so the get first name will give you Ann, get last name will give you Dawson, but for the person 2 object, the first name is Tom and the last name is Lee. So notice here we have 1, 2, 3, 4, 5, 6, 7, 8 print statements, and there we have 1, 2, 3, 4, 5, 6, 7, 8 outputs. So you will be able to connect each print statement to each output. So you should study the code, try to understand what's going on here. Maybe you'll need to review this movie or previous movies to fully understand what's going on here. Okay, so let's just close that shell. That's program 1302, and let's go back to our document. So those are the accessor methods. Now the opposite of an accessor method is a mutator method. Now to mutate means to change. So a mutator method will change the value of an instance variable. And we always call the mutator methods with a name that starts with the word set. So this is implying we're going to set a new value for this instance variable. So here, if you have two instance variables in your class, you need two mutator methods. And we're going to send a new value as an argument to this set first name value method. And the argument will be used to change the instance variable for that object, for the calling object. So if person 1 is going to call this person 1 object, if we call this method using the person 1 object, then the new name passed will be the one that's used to change the person 1 object's first name. And we can use, we've got a set first name mutator method and a set last name mutator method. Notice the first argument, the first parameter is self. Now you don't need to pass an argument self. In fact, you cannot pass an argument for self. This stands for the object itself that is calling the method. What you will be sending is a new value that will be used to change the value of the instance variable. So mutator methods change the value of an instance variable, and you can see this in program 1303. Let's have a look at program 1303. And here we've got the two mutator methods. And now remember, a mutator method will change the value of an instance variable. That's its purpose. Mutator methods always start with the word set, because you're going to set a new value. That's different to the accessor method, where you're just going to get the value but not change it. You just want to see it. So this is a read-only method, but this one is going to set a new value. It's going to mutate. So it sets the new value for the instance variable. Now, you've seen this code before. We've seen the get, but now to set a new name. So what I'm doing in this code here, person 1 has got a name, first name Anne, last name Dawson. So if I set the first name of person 1, change it from Anne to Annie, then when we use the get first name method again, we'll see that the name has changed from Anne to Annie. So let's try, I won't bother copying the comments, but I'll copy the code for program 1303 and place that and overwrite my Python program 1302. So let's paste that. Now this is a new file, so I'll save it as program 1303.py, and so it's basically the same as 1302, except that I've created two mutator methods, and these, we have one mutator method to change the first name and one to change the last name of the instance variables, first name and last name of the object. So if I run this, the very last line will print the new name of person 1, which will be Annie. And run, and there it is, there's the new name, Annie, which was obtained by calling the get first name from person 1. Now here we made a change to the first name of person 1 to Annie, so the new name which will be printed will be Annie, and you can see that there. Everything else we've seen in the previous code. So let's close this one and go back to here. Now you can have other methods. We've had accessor methods, mutator methods. You can have any method you like, but always in a class you'll have the init, the str, and accessor methods, mutator methods, any other methods that you wish you can make. So here, for example, I've got a method called reverse name, and the purpose of this method is shown in the docstring. It reverses the full name. So this method, I want it to reverse the last name, then a space, then the first name. And you'll see this in program 1304, and once you've defined this method, you can call it by using the object name, a dot, and then the name of the method you want to call. Now if we print the returned value, it'll print the last name followed by the first name. Now if we look at program 1304, you'll see the reverse name method here, and there it is called here. So if we use this method on person 1, it'll return the name Dawson space Anne. If we use this method on person 2, it will show Lee space Tom. And I'll let you run that one. Now if I go back here, abstraction is the next topic, the next important concept of object-oriented programming. So what is abstraction? Abstraction. Basically, encapsulation leads to abstraction. Encapsulation means that the details of how the data are stored and how they're manipulated, all those details are hidden. So that's all, that information is encapsulated. It's hidden from the outside world. Now the user of a class's methods only needs to know what's required as the input to a method, that's the arguments, and what's expected as the output from the method, that's the returned value. Now the user of a class's methods don't really need to know how it does the work, how it's implemented. All the user wants to know is, if I give you this input, what output am I going to get? So the user of a class's method only needs to know what's required for input and what's going to be returned. They don't care how you implement that method. So this is treating a method like it was a black box. A black box treatment is called abstraction. Let's have a look at the little diagram here. This is an example. So if you've got a square root method, you're going to give the square root method an input. Let's call it n. N is a number. It could be 144. You pass 144 to the square root method, and the output is going to be the square root of the value n. So if we send 144 to the square root method, the output will be 12 or 12.0. So we don't care how it does this. All we care about is that if I give this square root method a number, it's going to return the square root of the number. So a user of this square root method, they don't really care how you do this as long as it comes out with the expected value. So abstraction, it's the black box model. As long as the calling object knows what to send to the method and what's expected to come out of the method, then that's all that's required to be able to use the method. And now, how do we communicate to a programmer the behavior, the input and output of a method? Well, we've already been using docstrings. The docstring explains the behavior of a function or a method or a class. So for example, we have a method called average quiz, and this could be a method of a class, or it could be just a function in your regular program. And the docstring here tells you what's going to be the input and what's the output of this method or function. So the docstring tells you, in this case, that there will be 3 arguments. The first is a string, the second is an integer, the third is an integer, and this function will return a value which is a floating point value. And that floating point value is the average quiz score for the student. So the docstring is highlighted here in orange. And this is an example of using a docstring to explain to the programmer the required inputs and the output from this method or function. So we've talked about encapsulation, encapsulating, hiding your data within a capsule, within the object. Abstraction is treating a method as a black box. As long as the programmer knows what is going to be sent to the method and what's going to be returned from the method, how the method is actually implemented is irrelevant to the user of the method. Now, inheritance is a very important concept with respect to object-oriented programming, and so I'm going to spend a little bit of time talking about inheritance here. So inheritance allows you to define a new class from an old class, from an existing class. So we could have a new class. Let's say we've got, let's put this in more detail. So we want to create a new class which has some of the characteristics of a class we already have. For example, we could have, let's have a look. We could have a person class that has instance variables, first name and last name, but we want to create a new class called student. Now, we know that student also has a first name and last name, but the student is a more specialized case because we want to also have maybe a course code and a GPA and a quiz score. So let's go back. We have a new class, maybe we want a new class called student, and that's going to be created using an existing class called person. Now in this case, the person class would be called the superclass, also known as a parent class or a base class. These are all the same name for the same thing. Now, the new class, the student class, This is called the subclass or the child class or the derived class. They all mean the same thing. So essentially inheritance means making a new class from a class that already exists. The new class could be the student class, which inherits from the person class. Let's have a look at an example here. I should say that the subclass inherits all the properties, the instance variables, and the methods of the superclass. So for example, the person class has the instance variable first name and last name, and accessor methods and mutator methods. If we create the student class using the person class, the student class also has the instance variables first name and last name and all the mutator and accessor methods that the person class has. So here is how to create a new class called student from the person class. So we're creating the student class from the person class. This is an example of inheritance. Now, as the student class is a special case of a person, so we can say that the student is also a person, the student objects need all of the attributes of the person class, that's the variables and the methods, and it will have extra attributes of its own, like a student number and the GPA. So here I've got an example of how to create the new class called student from the person class. So again, we've got the docstring for the student class, and now we have the init method, which is slightly different here because now we're creating a student which takes the first name and last name from the person class, but also has a student number which is initially set to 0 and a GPA which is initially set to 0. Now when we have a class that is made using inheriting from an existing class, we have to use the init method of both classes. Now to call the init method of the superclass, the person class, we use the super method. So super, we're calling super on the init, so this will call the init method of the superclass, and the superclass in this case is the person class. Now let's have a look here. So we have the docstring for the init method for the person class and the docstring for the init method of the superclass, which is the person class. So these init methods will initialize the first name and last name, and for the remaining values, student number and GPA, we've got the last two statements here. So example program 1305 shows you how inheritance is programmed, and I'm going to have a look at example program. Now let's go back to my example programs, and 1305 is in fact currently the last program of the example programs. Now here we have the init method for the person class. Now, so this is the regular person class, we've seen this one before, but now we're going to create a student class and inherit from the person class. So we have the regular get and set methods can be used from the person class, so all of these methods that exist in the person class can also be used in the student class, because the student class inherits everything from the person class. That's all the methods, and that's the instance variables and the init and the str methods. And let's see here. So here we've got the student class. This is a new class. We're creating it from the person class. And here we have the docstring for the student class. And here we have the init method, which is creating the first values for first name, last name, student number, and GPA. Now, the init method for the student class, the docstring, is here, and here we're calling the init method of the superclass, and this will import all of the information, first name, last name, from the person class. So the superclass will initialize the private instance variables first name and last name, and the remaining statements here of the init method will initialize the student number and the GPA instance variables, and these will be taken from the parameters here. So extra accessor methods are required to get the student number and the GPA, and because the student number and GPA, they did not have methods in the person class. The person doesn't have a student number or GPA, but the student object has a student number and a GPA, so we'd need these two new accessor methods. And we also need the mutator method so that we can change the student number and the GPA of any student object. Now, we've also got a reverse name method for the student, and this one is different to the reverse name method for the person because it includes the GPA of the student. So here we've got a method which has the same name as a similar method in the person class. So here we've got the same name. So if we have a person object and if we have a student object, then we want to call this reverse name method for the student object and not the method of the same name in the person class. So now when we call the reverse name method on a student object, it will use the reverse name method of the student class and not the method of the same name of the parent class. Now, this is an example of polymorphism, which I don't really go into much detail in my document. Polymorphism, very simply, so we can have a method of the same name in two classes. And we've just seen that the method, let me see, let me go back to my page here. Right, we've just seen a method called reverse name that exists in the student class, and we have a method of the same name in the person class. Now, if we have a student object, the reverse name method that will be called is the one that belongs to the student class and not the person class. Now, a subclass such as student can change the behavior of an inherited method. So we have the reverse name method, which in the student class is going to behave differently to the reverse name method of the parent class, which is the person class. So we say that the method in the child class, the student class, overrides the method in the parents class, which is the person class. And so this feature of every object-oriented programming language that allows two classes to have the same method name but with different implementations is called polymorphism. Now, the word polymorphism is derived from the Greek word meaning many forms. Poly means many, morph means forms, many forms. So we have a function or a method which has the same name but has different implementations in the different classes. And if one class inherits from the other with a method of the same name, then the derived class, in this case the student class, the method reverse name will be the reverse name that belongs to the student class. That's the one that will be executed. So here we have the student object, and the reverse name method will be the reverse name method of the student class. That's the one that will be executed, not the method of the same name in the parent class, the person class. Now this is an example of polymorphism, and that's an advanced topic, and it will be dealt with in more detail in subsequent movies, but for now we'll leave it at that. So all programs can be found here, and that is the end of my video on programming, object-oriented programming using Python 3.